Welcome to another performance clinic. Today the topic is AIOps done right to enhance Dynatrace AI root cause detection. We definitely make sure we have a long title, right?
Yeah, absolutely.
Yeah. Hey, with me today, Wolfgang. Wolfgang, you may want to introduce yourself quickly. What's your role within Dynatrace?
Sure. So I'm part of the product management team here at Dynatrace, responsible for Davis AI since 4.5 years actually.
Mm-hmm.
And so everything that is dedicated to statistics, advanced baselining, automatic baselining, and root cause detection is in my ownership and handled by my teams. So
pretty cool. That's actually a pretty important piece of the product, obviously, right?
Yeah, it's one of the central pieces, actually. Yeah, I would say.
I would say so too. So now you did a great job at Perform in Vegas, talking about AIOps done right. I know you also wrote a couple of blog posts recently. There's also a couple of other webinars you have been doing and you are going to do. And I want to take the chance to invite you to the performance clinics to also talk about what's there, what can customers really leverage when it comes to AIOps. And without further ado, please take it away. I will cut my video stream because I'm going to go silent. And take us away.
Sure. Perfect. Thanks for the introduction. Let's talk today about or dive deep into the new functionalities that Dynatrace Davis offers in terms of leveraging AIOps capabilities. We added a lot of functionality here and also openness, and I would like to give you an overview. And I also prepared some practical live examples, so expect some maybe some demo effects here, but I will try my best here. So let's start right into the topic. So what I'm immediately or at the beginning always mentioning is that AIOps is all about automation. It's much more about automation than about picking any fancy AI methodology or even complex AI technology like neural networks or anything in that direction. It's really about focusing on automation. And Dynatrace, as it was built from the start, so 7 years ago, really was dedicated to automation. So the initial focus on building Dynatrace was to fully support automation with a no or very low amount of configuration necessary in order to get your monitoring up and running without no delay. AIOps, of course, is also about context, having the context about your operation, about your entire environment, what is depending on other components, and having that context in real time. So that means that Dynatrace, as monitoring very large environments, interprets the underlying model in real time and follows or measures abnormal behavior and the normal system behavior and alerts on abnormal situations. And that also means that by alerting on abnormal situations, we also provide actionable context and root cause along with the problem in order to derive operational actions, which is one of the most important aspects within AIOps tooling. So first of all, before we jump into the details, I would like to give you an overview how Dynatrace analyzes a lot of different data sources, how Dynatrace sets those data sources and those evidences that come out of the data sources into a larger picture and to gather the context of complex situations. And I would like to show you that in terms of a real-world example here. Basically, what we are focusing here is on three main aspects. The first aspect is Dynatrace monitoring and alerting is fully automatic. So that's one of the most critical aspects here. So everything, once you installed an agent, is fully automatic. So gathering the topology, the dependencies, the baselines, and learning the typical response time behavior of all your systems, learning about new services and applications is fully automatic. The decisions derived on that automatic gathering of information is smart. So we apply smart algorithms on top in order to find out what is happening, what is dependent, and what could be the root cause of a complex situation. And as one of the newest parts here, we also are open in terms of letting you feed the AI or let you feed Davis in order to send in interesting contextual or business related information in order to find out what could be the business process related root cause, or who is responsible maybe if there is a, for example, configuration change or deployment that happened. And I will focus on those three topics as of today and then show you a live example or several examples. So first, let's see automatic. So what happens when you install the agents is, and you can deploy the agents automatically. So even the rollout of those agents is fully automatic. So there is also, if you look into the Dynatrace API, there is the possibility to use the deployment API in order to fetch the dedicated agent for your platform and to roll out the agents in a fully automatic way, which many of our customers are doing actually. That means you can apply the agent on thousands of different hosts that you're running or virtual machines that you're spinning up or scaling up and down in a dynamic way. And all of those agents are providing a bit of the full picture of a web scale deployment or a web scale environment that Dynatrace as such is monitoring. So every agent is providing some dependencies, is monitoring one piece of a complex service structure, and out of that, Smartscape evolves over time. Yep.
Yeah, this is just thanks for letting me interrupt you here because questions are coming in.
Sure.
And also, first of all, as a reminder that you can ask questions. You talk about the automated rollout of agents, and the first question that just also came in is, can we deploy the one agent with tool like Puppet, Chef, or Ansible that we're currently already using in our organization?
Yes, you can. So there is different kinds of entity types that our model identifies out of the box, which means the agents or Smartscape identifies virtual machines, running technologies, as well as disks or whatever is running in your environment automatically. It assigns a type. So we know exactly that VM is running on a hypervisor and so on. Mm-hmm. We know that the types of those monitored entities, and out of that, along with the real-time communication that happens between the components, Smartscape evolves in real time. Mm-hmm. So whenever you start up a new process on a host, it immediately shows up in Smartscape. It's classified as sort of technology. The services in that process are automatically detected, and we immediately start to gather a baseline to measure the normal behavior of that system component.
Perfect. Cool. There's a couple of other questions that are just coming in, but I think we will address them at the right moment in time. So,
sure.
But thanks for letting me go.
Sure.
One second. Yeah.
Okay. So I already mentioned that one of the major strengths here in terms of automation is the automatic visibility across a multitude of different technologies. So it doesn't really matter if you're running a Go microservice that is calling a Node.js microservice in the backend, and that again is calling a Java service. All those services are automatically identified, monitored by Dynatrace, and the baseline is technology agnostic in terms of measuring the typical behavior of your services. No matter what combination of technology you're operating, one agent is detecting that. It's baselining the normal behavior and tracing across multiple different technologies, including cloud technologies, as you can see here, like Cloud Foundry, AWS, and so on. So that everything forms a huge, big picture what is going on in your environment. So, and what about smart here? So, as I mentioned before, I would like to show you the different data sources and how they are seamlessly integrated in a root causation detection process. So basically, I will replay how Dynatrace Davis analyzes a complex and critical situation in your environment according to some technologies that I will mention here. So the first thing that you will notice is you're probably monitoring a web application, and the web application is transferring real user information, digital experience monitoring information directly to Dynatrace. The application is automatically baselined with a multidimensional cube. I will explain that later on how that works. And once there is some degradation of the normal behavior detected in terms of real user affecting change, either in terms of traffic, errors, or user action slowdowns, and so on, we will raise a single event on that application. So what then happens is Davis takes over and will automatically analyze based on the rich context that we have where the application is running on. So which technology the application is provided by. And it finds out that it's running on a web server cluster. It collects the individual instances of that web server cluster in real time. And it identifies, as is shown here, that the underlying topology and the underlying infrastructure doesn't show any abnormal behavior. Not in terms of events, metrics, whatever, no resource contention here that we can measure. And so that means the root cause of the application slowdown or the application problem has to be in terms of backend services that the application is depending on. So Davis automatically follows all the transactions that are coming in from the application side. And here we have the transactions as one of the most critical data sources that we have in Dynatrace. It follows all the real-time transactions coming in and finds out that the application is calling a Node.js microservice in the backend. And as we see here, the baseline or the normal behavior of that Node.js microservice behaves in an abnormal way, so that we identify that the health state of that microservice shows an abnormal behavior. Again, we have to first check if the underlying infrastructure is the root cause or could be the root cause candidate for that situation. And we follow that down to a microservice cluster running in Docker and in Cloud Foundry. What you can see here is the data sources here that are extremely important for us, which are automatically analyzed, are number 4, the code level information. So what I would like to stress here is that tracing is not the only critical information. It's rather more the code level information that Dynatrace provides that gives us a detailed information about the resource consumption of each individual call that is coming in, hitting that microservice. So Dynatrace Davis knows that what CPU consumption and memory consumption each individual call has that hits that microservice. And if we follow that down in the topology, in the vertical topology, we see a lot of metrics. So in average, around 500 different metrics per host, depending on the technology that is running on that host. And we are also seamlessly integrating the cloud platform metrics in terms of what is going on in your Cloud Foundry application and containers. Again, there is nothing wrong in the underlying infrastructure, and we are following again the call tree to the next critical backend service that the Node.js microservice is calling. And as you can see here, that process is completely technology agnostic. So meaning we are crossing host, cloud, and technology boundaries here in order to find the root cause. And that's fully automatic. You do not have to configure anything single setting here. And in this case, we are calling a Golang service running on a Golang process on a Windows host. Again, we are analyzing all the events, meaning external, internal events sitting on those processes, like process crash events and so on. And of course, one also very important information, all the log files that the processes are touching or the host is touching. Yep.
Actually, before you go on, I'm sorry, I see you still have the third-party events, but the question just came in, and I think I want to just throw it. So in this scenario, you have 2 Linux hosts, a Cloud Foundry environment, and a Windows host. Can you explain again what you need to install to get this level of visibility and this level of dependency mapping?
Yeah. So in terms of a bare metal Linux host, for example, you just have to put the one agent on that host. Mm-hmm. In terms of Docker containers, you have a build pack that you can install into the Cloud Foundry application. In case the Docker container is running on an instrumented host, like a Linux host already, our instrumentation or our monitoring is fully automatic. So you do not have to install anything or configure anything in order one agent detecting the Docker container. Mm-hmm. And the same on the Windows host. So you just download or automatically deploy the one agent on that Windows host and you're set and running.
Cool. And I think for Cloud Foundry we also have a Bosch add-on. So when Cloud Foundry deploys, Diego cells will automatically get deployed. And for PaaS platforms like Kubernetes or OpenShift, we have the operator even, right? It's easier, right? You don't need to touch anything in the container. I think that's the magic. So cool.
Okay, so mentioning the last but not least information that we added here, which is the third-party events and metrics that you can ingest into Dynatrace. So meaning all those participants in that complex situation can be addressed by external events also. Meaning you can send in any deployment event, informational purpose events, enriching that root causation detection by your own information coming from your own tool chain, deployment tool chain, load test environments, and so on.
Mm-hmm. Another question that just comes in that perfectly fits here. will the AI, Davis in this case, also consider problems that are generated from custom plugins? So if you write a Dynatrace plugin, right, you can feed data in from external sources as well.
Yes.
Will this also be considered?
Absolutely. So I have a slide afterwards about that, mentioning that. So for Dynatrace Davis, it makes no difference if the metric or event is coming either from API, internal, one-agent related sources, or from your custom one-agent plugins or remote ActiveGate plugins as such.
Cool.
So there's no difference. So maybe a philosophical question, what is normal? So how does Dynatrace detect what is normal? And what did we change due to our recent enhancement that we introduced? So typically you're using baselining in order to find out what is normal. In case of Dynatrace, we have a highly sophisticated automatic and multidimensional baseline in place. So that's a bit hard to imagine how that looks like, but I would like to give you a quick introduction in how that works in reality. So first of all, you do not have to configure anything. That's done automatically. You do not have to do anything or think about how you would do that. Just imagine you have a web application where you get a lot of traffic coming in. And the traffic, meaning millions of user actions per application, per minute, are coming in as a stream. I show that here as one of the first user actions that is coming in when we start the stream is payment from New York with Firefox browser and Windows. And so it is going on. The stream is going on endlessly, millions of actions per app per minute. And you see there's a logout from a different user, probably from Orlando, with Chrome 50 on Linux and so on. There's a favorite icon fetched and so on. And what Dynatrace automatically detects here is it generates an automatic baseline cube, we are calling that, a multidimensional cube that contains all those dimensions that you see here. So the dimensions are user action as one of the most important ones, like payment, logout, and so on. The geolocation, like New York, Orlando, New York, and so on. Which browser the user is using. And you see here, I'm restricting my visual to 3 dimensions, as it is hard to visualize that for 4 or more dimensions. But we also have the operating system, so you can add that on top. And what is calculated here in real time is each individual cell is a combination of user action, geolocation, browser, and operating system. And Dynatrace is detecting where those most active cells are coming from. So it's collecting the top cells automatically, and this cube then reflects the most important user traffic that your application receives. So if most of your users are coming from New York, you can be sure that we have a reference value for performance, for error and load for New York, for those specific users in place. If your load and traffic pattern changes, you do not have to care about that because Dynatrace automatically adapts that. So we are learning over time. So if your application traffic shifts from New York to Orlando most, or to China, whatever, also the cube will change. It evolves. And it will also automatically forget old cells, which are no longer important, which is also a very important benefit here, because you do not have to worry about storage or whatever. We keep track of that. And we age out old patterns that are no longer relevant for you.
So, Wolfgang, if I relate this back to what we used to do with AppMon, our second generation product, which is also kind of aligned with what other APM vendors are doing out there, back in the days, we had to manually configure what are the combinations that are important for us, right? And that is all gone.
That's all gone. Yeah. So what you can do to interfere and to interact with that mechanism is you can pin a user action. So if you think payment is one of the most important ones, not very frequent, probably you can pin it. So you can tell Davis, this one is an important one, don't forget about it. But usually that's not necessary. Everything is done automatically.
Cool. And now the example that you bring here with user monitoring data, I assume the same is also true
for services.
For services, yes. API call, REST calling, and all that stuff. Yeah.
It's a bit different because we are operating a different cube for services and also a different cube for database services. Okay. For example, for database services, there are certain groups in order to cover database inserts, updates, queries, rather than real user actions like payment. So it's different. It's a different cube. And what I also like to show here, due to recent questions from our competitor side, we have a lot of different metrics in the baseline cube, as you can see here. On the performance side, you see that we are calculating speed index, time to first byte, response time, visually complete, DOM interactive, load event end, and so on. In parallel, all those metrics are in the baseline cube. So what about 1 million infrastructure metrics then? We talked about real user affecting baselines and metrics. So what about the million infrastructure metrics that Dynatrace covers that are dramatically increasing actually because there are a lot of different technologies, a lot of different insights that Dynatrace detects automatically. And how do we cover that without triggering false positive alerts? So how that is done for infrastructure metrics. So let me introduce you a new feature that we have in our next generation AI engine published, which is the change point detection or the abnormal metric change detection. So given a time series that we find along the way, so I showed you before the topology that shows the problem affected topology in vertical and in call traces in horizontal way, then we are identifying if any of those components is showing an abnormal health state. And how do we do that with thousands of individual infrastructure metrics that are residing on the host or on the technology process? So let's take a simple example here of a time series. And what Davis does automatically when visiting that component is it moves a separator between the different measurements over time, and divides the metric in the sample the sample set of measurements before the problem started and after the problem started. And Davis automatically moves that line and iterates through every minute. So imagine Davis doing that for all the 1,000 metrics on all the problem-affected components in real time. And what we detect here is we try to find if there is a delta between the distributions. So if you have a distribution chart of sample 1 and sample 2, you will see that sample 1 is shifted terms sample 2. So you see, through that moving of the line, we can detect where the delta or where the maximum of the delta between the two distributions is. And exactly where we hit the maximum delta, we identify that there is a change point, if there is a delta. So if the delta is below a certain amount, then there is, of course, no change point. But if there is a change point, we even detect where the maximum delta lies. And in that sense, we can identify abnormal metric behavior on infrastructure level, even without a threshold and even without baselining in that sense.
So Wolfgang, if I understand this correctly, again, coming back to the old days, how we used to monitor, building huge dashboards with many, many metrics. In your case, what you said, hundreds of thousands of metrics for your hosts. Yes. Now, Dynatrace is automatically walking through every single metric we have on the complete, let's say, smartscape that is part of the problem.
Yes, exactly.
So let's say there's an application problem or a service problem. We see there's 5 microservices involved running on that many containers, running on these many hosts. We automatically walk through all the metrics and figure out which of the metrics have an abnormal behavior. And we use this approach here to figure out if a metric has an abnormal behavior.
Exactly. Cool. That's exactly the process.
Perfect.
And that process and that approach avoids unnecessary false positive alerts. So if you would baseline all those 1,000 metrics in advance, and if you would alert on those, you would generate a proportional amount of false positives. Yeah. So if you think of millions of individual metrics, you would generate a lot of false positives, no matter how good the baseline is.
Yeah. And also it avoids obviously having to sit down and figure out what would be a threshold. It doesn't make sense to, for instance, specify a threshold on CPU anymore in very dynamic environments, right?
Absolutely. Yeah. And it works for your own metrics in custom plugins too.
Oh, that's pretty cool.
So you do not have to specify a threshold or even baselining. Whenever there is your own metric showing an abnormal change point in front of a problem, Davis would show that.
Pretty cool.
And that's exactly the drill down screen that I'm showing here that detects those metrics that are showing an abnormal behavior. So
I assume we see this live in the demo later on as well.
Yes, you will. Awesome. So, and now I'm coming to the third very important part, which is the openness that we added to the Dynatrace Davis. And it allows us, or it allows you to consolidate and integrate all of your tools that you're operating. You can enhance the root causation process by integrating your tool chain. And this is directly, this was built according to your customers' feedback that you provide over the last 5 years. So Dynatrace One Agent provides a lot of information, but you're obviously operating different tool chains, and you would like to take part in that root causation process. And in many cases, you have very interesting information to share with Davis that can be used in the root causation process. And from our perspective, the transactional information and the code level visibility is the only valid connector between those individual isolated events. So if you share those events with Dynatrace, we can correlate and combine them to a consistent view, and you have a single point of view. Let me give you an example here. How would you provide an external, in this case, non-metric, there are metric events and non-metric events. How would you provide that in terms of Dynatrace? And I chose an example here that could be interesting for you, which is an uninterruptible power supply that has the capability to alert on when it's used or it's turned on in case of a power outage. So typically you have some half an hour left then in order to fix the problem. And that's an important information, I guess. And so you can use Dynatrace, or you can use that interface in order to send that information in. So in case that you lose the connection to the host, and Dynatrace will report host outage, you would have that information about the power outage attached to that problem. And as you can see here, you have certain amounts of information that you can provide. There is event type. It goes along with the severity levels that Dynatrace has. In this case, it's an error event. You have a title of the event and a description. There is a timeout feature, which means you can set a certain timeout that the problem stays open and where it's ready for correlating with Davis. So, and you can refresh that. So you can specify a timeout in minutes of 5 minutes and then refresh the event again until the problem is resolved. There is an attachment rule. Either you apply that to a specific host or to an application or whatever you would like to attach that event to, or you use a tagging rule. So you can say, well, please put that event or that problem to all hosts that have the tag clinic sitting on it. I also specified the data source here and some custom properties that you can select according to your use case. And let's trigger one of those. So I'm jumping over to my REST tool here. And as you can see here, it's completely the same payload that I showed in the slide. I submit that as a HTTP post message here. And I get back that it was correlated into an event. It was assigned one time on a host with that ID here. And if I switch over to Dynatrace, I see my custom title here, power outage. Impacted component is the host. If I drill down to the host, I see that the clinic here, the clinic tag is correctly attached here. And I have my custom details shown here. So the source is my UPS 123 running in data center south, whatever. There is an estimated remaining time left to fix the problem of 3 hours, or what you decide. Yeah, and Davis keeps track of that, so it correlates incoming issues along with that event that you sent in. Let me go on. So that's one example for a trigger event. But we do not only have trigger events that open a problem, we also have informational purpose events that you can use in your pipeline in order to inform Davis about informational contexts like deployment changes, configuration changes, and so on, that do not automatically trigger a problem, but are correlated in case that a problem appears. And as I said before, custom events and metric sources are completely transparent across the sources. So either you use a one-agent custom plugin to send events or metrics. You can also use a JMX, PMI-based plugin, an ActiveGate plugin, or use external REST API, even external synthetic REST API is possible. So there are all different kinds of options to contribute. And now I'm switching over completely to my live demos. One example I already gave. I prepared a very simple Go web service, and it simply returns hello world here. It's depending on some second backend service, and there is a neat trick inside. So whenever I add a parameter slowdown is true, then I trigger 200 slowdown or slowed down answer requests. And let's trigger that for now. And meanwhile, before that happens, I would like to switch over and show you how an informational purpose event can be used and sent into Dynatrace. So, for example, a deployment event. So in this case, I'm sending, I changed only the event type to a custom deployment event, and I'm putting the information, the event, on a service with a tag stock ticker on top of that. I also have a CI backlink and a remediation action link that you can see here, and some custom parameters here. And if I send that as a post, I again get that it was attached to one entity here. Mm-hmm. And how can I use that as an integration purpose? I can convert that to any kind of curl command or to whatever, and you can use that in your own build pipeline. And what I did is I created a small repository. I called it simple in Bitbucket, and the repository triggers Bitbucket pipelines, which is an integrated feature here to trigger a build automatically whenever there is a commit happening. And whenever I do a commit here, build happens, and the Bitbucket pipelines, a YAML file, controls what happens. And in this case, at the end of the build, I execute a bash script here that I called push event. Mm-hmm. The push event is part of my repository. You can find it here. And it exactly shows the content that I pushed before, like custom deployment. I'm pushing it to a service with tag clinic on it, and I'm using the placeholders that are filled with dynamic information from Bitbucket pipeline here. Mm-hmm. And in order not to expose the token, I used the Bitbucket repo in order to provide the Dynatrace token here. And let's change the source code here, like whatever. I don't have a README file here, but let's add something to.
While you're editing this, just
for the commit.
Yeah, for the
just
commit,
for the commit.
And while you're editing this and forcing a build, just for folks that are using other CI tools, as you mentioned earlier, you're really just executing curl commands. So you can do this from Bitbucket, as it's shown here. We can do this from Jenkins, from Concourse, from Circle CI, from Travis. We can do it from anywhere. For Jenkins, for instance, we also have a great plugin already available that is called the Dynatrace Performance Signature plugin that also includes a feature for the Jenkins pipeline where you can also post a deployment event over to Dynatrace. So this is a really cool thing and makes it very flexible. And I think one of the main use cases that I at least am promoting is hooking up your CI/CD pipeline with this, right?
Absolutely.
Over, yeah.
Absolutely. So it's your choice which toolchain you're using, and typically you have one favorite toolchain in place in your enterprise. Yeah. And as we see, the push of the event went through. The execution of the event push should have happened already. And let's switch over to see. How did I push it, actually? Let's see what happens here. We got the event sent over from right now from Bitbucket pipelines, and you see that this Bitbucket commit was added here by using the Bitbucket placeholders. And if we look at the response time here, we already see that the slowdown takes effect here. So there are my 200 requests coming in, And we should have possibly a problem soon.
You are in the problem context right now. I think you're in the problem context.
That's thanks. That's annoying.
So sometimes it's good that we sit in a room and I can actually tell you things. Because you reminded me about this many times. Yeah.
Good point. Here it is. So that's the new problem that was opened. And you see that there was already response time degradation detected. We see the abnormal behavior of the metric itself. We see the deployment event that was coming in. Mm-hmm. And if we drill down into the code level details, you will see the code execution here. And you see exactly where I put the sleep into the code that uses that amount of additional time to respond, mm-hmm. which is in my say hello go routine here. Mm-hmm. So it's a very simple example, but it perfectly shows how that process of the root causation is happening, how we are following the transactions that are coming in, and how we are blaming the root cause component automatically. Yeah, so I'm through my planned examples. Of course, this is a very simple example. I also prepared one that shows a bit more complex example with a lot of different components that are involved, just for reference. This is a more complex example involving several applications, a synthetic check, and so on. A lot of backend services where a lot of degradations are going on.
Wolfgang, if I see this now, I mean, this is obviously part of the Smartscape that shows all the components, services, processes, hosts, all the entities that are affected, and that means, based on your explanation earlier, Davis now goes through every single of these entities, looks at every single metric, and figures out which metrics have an abnormal behavior.
Yes, absolutely. And it's a hybrid approach. So either Davis finds an event that is already sitting on those. So if you decide to nevertheless go with a threshold or a baseline, then we find the event sitting on it. Mm-hmm. If there's no event, we nevertheless check all the metrics for abnormal behavior. So we can run with or without the event sitting on it.
Yeah. So that means with an event, you mean a custom alert. I can say I still want to have a certain threshold on some metrics because I know these are critical thresholds. Yeah. Well, that's pretty cool.
And you see the deployment changes here that happens and so on. So that's a rather complex example. And if we drill down into the root cause, the change point detection here, you see that all those metrics are moving. There are several instances involved. So you see there are 7 check destination instances involved of that check destination service that are all spiking in case of that problem. Yeah, so that's it from my side.
Hey, do me a favor. There's a lot of questions that came in. Before we go to the questions, can you quickly walk over the slides again? Because I think we have one or two final slides, and then we can also put the cameras back on. I actually turned the wheels off earlier because I wanted to give people more space to see the demo. But feel free to turn. I think maybe I can even remote control. I don't know if it works, but you can probably turn it on again.
So quick summary. I talked about automatic smartness and openness of the new solution. I explained how the process runs in a time boxed manner so that you can follow how Davis is analyzing a complex situation. I showed some examples in real world, and how you can integrate with external tool chains. And with that, and there are some additional links attached that I collected that give you more context and information. And with that, I'm handing over to Andy again.
Cool. And then turn on your camera. We both have faces that can sometimes hesitate to show them on live television. The last thing that I want to say, we already had Perform Vegas at the Cosmo just a couple of weeks ago, but there's Perform Barcelona coming up, right? The European equivalent to the big show. So I would highly recommend everyone that is in Europe or wants to come to Europe in May to go to perform.dynatrace.com and check out the Vegas events and the Barcelona event. Vegas will happen again, obviously, next year. There's also other regional events, so make sure that you sign up there. I think there's one more slide, if I'm not mistaken, if you can do me the favor. I guess just a thank you. That's perfect. Yeah, you can obviously get your own trial. That's great. And there's a couple of questions that I want to get out right away. Certain folks have said they came late to the webinar, or are the webinar, is the webinar recorded, are the slides available? So yes, and yes. That means that the webinar is recorded. It will be put up on the YouTube playlist that is part of the Dynatrace YouTube channel. The playlist is called One Agent Tutorials, Performance Tuning Tutorials. It also gets uploaded to the Dynatrace University. So university.dynatrace.com. You can click on Dynatrace and then you can go to the webinars, and there you'll see every previous webinar, also this one. And we will also upload the slides. So in case you want to have the slides as well, you will see them there as well. Now there's a couple of questions, and I want to start from the top. I think this one came in when we talked about Smartscape. The question is, can we deploy an agent on S3, or will that ever be possible? I mean, my counter question was, what do you really want to monitor in S3? For me, S3 is a service from AWS where we can pull in CloudWatch metrics. So that's something that we're currently working on, that out of the box with our AWS CloudWatch integration, we will pull in metrics from S3. Right? I think that's the better approach, because it doesn't make sense to install an agent on S3, but you want to get metrics about
on
S3, right? How many accesses do you have? What's the performance, the bytes transfer, and all that? Yeah. Next is an interesting one from Amit. Is there a way to tell the AI to ignore certain problems where the root cause is known? So for an example, what if we have an antivirus scan running on a regular basis? Can we, for instance, say ignore high CPU utilization on a particular server as a condition? Can we do that?
Not as of today. I mean, what you can do is you can define a maintenance window to ignore that time when the virus scan is running and reducing your system performance. And that also helps you to, what the maintenance window period also does is it excludes the time of the baseline in the baseline calculation.
Great, yeah.
So if your services are degrading a bit during that virus scan run, then we are ignoring that reduced performance in the baseline calculation. So that's one way of doing it. In the other sense, we are planning a feedback mechanism in the problem section, where you can tell the AI to ignore certain things or to upvote certain root causes. So that's on my roadmap.
That's cool. And I saw you recently, or maybe it's been already a couple of months, but fairly recently, you introduced an API call where you can automatically close a problem also from the outside and also add comments to it.
Yeah, you can comment and you can close a problem in the UI. In the API, it will come in the future.
Cool. Perfect. Last question to the maintenance window. You can specify a maintenance window on certain entities.
Yes.
So that means you could be, so Amit, hopefully that answers your question. You can create a maintenance window on that particular entity and say, hey, ignore that time frame. Yeah, that's perfect. Santosh, you asked the question about running it against SAP. I assume you mean, can we use Dynatrace to monitor SAP? You may want to follow some of the stuff that SAP is actually doing with Dynatrace. So they've actually been on stage at our conference, and they talked about how they're monitoring, I don't even know how many thousands of servers and how many 100,000 of containers. So SAP itself is actually using Dynatrace in their cloud environment, SAP Cloud. Also their Hybris, their commerce team is using it. So the answer here would be yes. Let's see. The next question is there a scalability report that I can use for forecasting my server network, memory, cluster utilization? Then I asked another follow-up, and Frank got a little bit into more detail. For example, my app serves 100 users at 100 seconds per user session in the app. Then at 200 users, the app takes 125 seconds per user, and so on. This would let me forecast the amount of users my app supports. And my answer was, this is something you can just put on a chart, on a dashboard, and you can query these metrics.
Yes.
For the REST API.
You can.
Yeah.
There's one feature in the REST API even where you can forecast a certain metric. Okay. So you can select the metric and forecast that. But the forecast so far is limited to half an hour. Beyond that, even with other solution offering more than up to 3 months, what I saw. But my statistical experts told me that the confidence level or the band that spans the confidence in that prediction gets huge in terms of beyond half an hour. So, but there is an API feature for predicting metric into half an hour of the future in order to solve or to offer some help in scalability planning as such. Cool. Otherwise, you get all metrics through the REST API. Yeah. You can play around with them. Yeah.
Cool. Mike just gave me an update on his S3 question. So his question was actually centered around, I'm hosting my app on S3. So I assume you're talking about your client-side code, the JavaScript files and all that. How can we trace pure paths to end-user sessions? So Mike, if I understand you correctly, if you host your JavaScript files, your HTML files, whatever it is, your front-end application, then you can instrument these files just through our run manual instrumentation. That means if you're going into Dynatrace, you have by default, the one agent does automatic instrumentation. For S3, you would go the quote-unquote manual way, meaning we give you the tag that you have to put into your HTML pages, and then we start tracing all of your end users, even though your app is being distributed on S3. So right, hopefully that makes also sense from my side. Amit says he's tried maintenance Windows before. That was the guy who talked about the antivirus, and he will drop us an email for further on questions.
Okay.
That's great. Yeah. Luis says, I'm using Dynatrace for more than a year now. How do we reduce noise alerting to avoid unnecessary calls with problems? So to give you an example, SQL that responds from 10 milliseconds goes from 10 milliseconds to 50 milliseconds. So I assume Dynatrace obviously sees this as an abnormal behavior, but I guess, Luis, you're going into that direction where you say, well, I don't want to be alerted because it's still good.
Yeah, well, there are certain possibilities. So, of course, on top of that automatic baseline, you have the possibility to raise the threshold above the baseline. So you can adapt that and add additional thresholds above, which is possible. Yeah. And another way would be to use alerting profiles in order to filter out small hiccups that are not open longer than X minutes in order to reduce the amount of alerts sent out by Dynatrace that are just involving smaller hiccups like 5 minutes or 10 minute spikes.
So Frank, whoever came up with that question, I just removed it from my input from the list here. Hopefully that answers the question. Let us know. Vladislav is asking an interesting question. Maybe we were unclear. He says, do I understand this correctly that the new Dynatrace AI does no longer use baselines? That's not true.
Correct.
Exactly. So maybe let's rephrase it. we are still calculating all the baselines that you explained earlier. We do multidimensional baselinings on all of your end-user actions, split by geo,
services, database services, everything is in place. So that didn't change at all. It's just the way that we detect root causes additionally on the underlying infrastructure has improved in that sense. Yeah. So the automatic baseline still in place, has its important role, and that was also the slide that I was talking about. So that's everything in place.
Yeah. So we see, for instance, an example, we see that the response time of the critical service for you, we have the baseline. Now the baseline is exceeded. We trigger a problem, but now what we do for the root cause detection, we look at all these metrics along the Smartscape tree and say which of these metrics is having an abnormal behavior. Yeah. That's what the abnormal behavior detection was all about. Pretty cool. One more question from Frank. Frank, and I think I answered it in the chat, but he was asking, how does Dynatrace handle secure environments? For instance, if we have REST API calls from one service to another using HTTPS compliant to server. I think he's talking about the end-to-end tracing. So Frank, if you've never seen Dynatrace in action, the one agent that Wolfgang was talking about, what the one agent is also doing is automatically instrumenting your services, your code, whether it's Java.NET, PHP, Go, Node. We instrument it, and therefore we can trace calls end-to-end because we sit in your application code itself. We sit in the process, and we don't have to. We don't look at your HTTPS connection from the outside, right? That's the difference. Just give it a try, right? You have the trial link here. So just give it a try in case you have not seen it in action. It's really amazing. Right? Magic, yeah. All right. Hey, Wolfgang, we're at the top of the hour. Thank you so much. Dynatrace Davis is pretty cool. And by the way, for those people that don't know, Davis is, I think, what we consider as being the magic from Dynatrace. At least, what you see at the end of the benefits you can reap from it. Remember also we have integrations with ChatOps tools, so you can actually talk to Dynatrace Davis. You can talk to it through instance Alexa integration, right? And
Slack, whatever. Yeah.
So it's pretty cool. We have a very powerful a very powerful API where you can pull data or you can push data. Cool. Thank you so much, and thanks for everybody listening in. And
thanks everybody.
We'll send out. Watch out for the recordings and get your trial. Bye bye.
Bye bye.